body which was established 28 years ago by like-minded people for the upliftment of structural engineering and unity, and to represent all the issues in front of government bodies, to comment on the draft codes which are coming up, then to organize some webinars, seminars, site visits, and so much ISSE has done in last 25 years. And for past couple of years, ISSE is also running student chapters and these kind of webinars for the benefit of students. And these all seminars, you all know, aware that these are free of cost. You should take a little benefit from these sessions. To know about ISSE more, you can log into ISSE website. So these are various publications which are given by ISSE. So this is a big book on which was published somewhere in 99. That is 25, 26 years ago. Then this is another code for this is another code for ISO. There was a workshop on ISO. Then this is a code on tall structure shear walls, how to design shear walls. Then this is a code for guidelines for the effective use of softwares for the buildings. Then there is a manual practice how to do. Then there are several more codes on high-rise buildings, foundations, and all. So I would suggest that you all participants can go through ISSE website and have a browse through this publication, so that you get a good feel about what is happening in ISSE and in the profession in general. So moving ahead, I will welcome P. Surya Prakash sir for today's talk. And before I hand over to him, I would just like to give a brief introduction of the session and the topic. And our ICC president would also like to express a few words. So before that, I will introduce today's speaker. So, welcome, sir. We all know that you have been a doyen in the field of civil engineering, structural engineering. Sir completed his graduation from JNTU Hyderabad in 1986. After that, in 1990, he completed his post-graduation in structural engineering from IIT Madras. Then after working for a few companies in 1994, he started his own company, that is Satyavani Project and Consultants, and he has been heading a position of managing director. He is also a trustee of Smart Infra EST. Then he was a president of Institute of PEB, and past 4 years he has been associated as a national council member of Institute of Engineers IEI. Over 35 years of a massive experience he holds in the field of design, consulting, various buildings, industrial plans, precast structures, and many more. So in today's session, you will realize the vast knowledge which he has. He is also passionate about technical training in various topics in civil structural engineering. And during COVID period, when everything was locked down, he conducted several wonderful technical lectures online, and which educated civil engineers. He has his own YouTube channel for the dissemination of knowledge in civil structural engineering. We find him a best or the excellent blend of professional and academic knowledge. Recently, Surya Prakash sir has already won several awards, but to name a few, recently he has won ACC Ultratech Award from the state government for his as a recognition of his excellent work. So before I hand over to Surya Prakash sir, I would request ICC President Shri Hemant Vadalkar sir to express a few, his opinion in a few words. Sir, over to you.
Hello, good morning, and welcome Surya Prakash ji to our student session. I just want to take 1 minute just to emphasize that Vivek Abhyankar has already introduced P. Surya Prakash. He has done wonderful work in, I think, civil and structural engineering as a design engineer, and he's running a good office in Hyderabad. But one point I just wanted to tell you, all the students, that during the COVID session, I think the offices were locked everywhere there was a lockdown and no one can work actually or move out. So at that time, P. Surya Prakash has taken the initiative and he started the lecture series. If I remember, I also attended some of the, I think, lectures of P. Surya Prakash, and it was wonderful experience. So this is actually what we are giving back to the society, and that's why I think we are all here. ISSE motto is same thing. We want to disseminate the knowledge. Actually, it's a knowledge sharing platform, we call it. And I request Surya Prakash ji, if possible, you can make a list of all your lecture series, and if you can publish it, I think maybe it is on YouTube, I know. But still, those who are interested, I can go to that series and refer that anywhere they want, they are interested in. So if that something can be done, I think we'll be also glad to share with you all this experience and what our ISS is also doing in that same direction. I think we have a great speaker today, P. Surya Prakash, and over to you, Surya Prakash, now. Thank you.
Thank you, Hemantji and Vivek, for saying few good words about me and my work. And definitely, I'll take your advice. I'll try to work on. In fact, I thought then itself in 2000, when I was giving these lectures, that I must document in hard form also whatever lectures I have given. For the information of the participants, there are 280 videos in my YouTube channel, and it has good number of views and number of hours of views. Many people follow my lectures in whatever topic they want. I covered 360 degree of my profession in those lectures. And during lockdown alone, I have given 60 lectures for 60 days. So that is the thing. And if you permit, I'll start without losing time on the topic of today, which is a topic very close to my heart. And and out of 280 videos also, this topic has the maximum views actually in my YouTube channel. About 13,000 views for the same lecture I have given during lockdown. So today also, because it is like high-rise buildings is order of the day, and the planning and design is the engineer's job in any project. And high-rise buildings is most fastest growing actually. In fact, Mumbai stands first with 60% of the tall buildings in India, and Hyderabad comes next. Hyderabad also is growing. So I, being from Hyderabad, I always try to cover this topic because it's very important for engineers to be updated and keep abreast of the developments happening in this segment actually. This is the fastest growing technology also. So I'll share some of my experiences and some of the works done across the world. And because for us to get motivated, we have to see what is happening in the rest of the world also. Maybe we can mute all other participants because it disturbs others. I request admin to mute all the participants. So today I'll cover about high-rise buildings, need for high-rise buildings, functional planning considerations, structural systems for high-rise buildings, and dynamic analysis, effect of wind, particularly on high-rise buildings, and planning and management of high-rise buildings, that is construction management. And also I'll cover on construction techniques that are available, safety measures, and then some of our projects, the case studies that we have done, and high-rise buildings, and reaching for the sky. That if time permits, I'll try to cover on design trends. So this is the order of my presentation today. So high-rise structure is a tall building, as we all know. Any building that is more than 15 meters, as per National Building Code, is called as a high-rise building. And sometimes in residential, we'll also call it as multi-dwelling units. And we know the need for housing is growing every day due to growth in the population, and particularly rapid urbanization that is happening in India. Most of the cities, most of the states are crossing the urbanization of 50% actually of the population. So we have to think of how we can utilize the land available and still accommodate the growing population. So that is the main demand and challenge that we engineers and planners have on hand. And it's a tall, vertically oriented structure. It influences design, construction, and performance. And of course, the maintenance and safety are very, very important. And wherever the land costs cross beyond, say, let us say 3,000 rupees per square feet, it calls for utilization of high-rise building. But another challenge before we think of high-rise building is the access roads. Unless we are seeing in nowadays in some of the cities, of course, they are not as per the bylaws, but people are building a 7-story building, 10-story building in a road width of 30 feet or 20 feet even. That's not to be encouraged or permitted by engineers because it affects the safety of the people living in the building and around the building. We have seen what happened in Nepal post earthquake. Actually, it is very difficult to evacuate. It is very difficult to rescue people, and relief, providing relief also is very difficult. Even for a fire engine in case of fire to reach the location is very difficult unless you have the minimum for a high-rise building, which is to be more than 15 meters. Even for 7-story, the minimum road width shall be 40 feet. So this is the thing we have to consider while talking about high-rise buildings. And it structurally, if we think about high-rise building, acts like a cantilever with adequate strength and stiffness and stability to resist the shear and bending mainly, and overturning effects. This is the main thing. And it demands for careful understanding of the structural systems because in fact, we all know the best designer in the world for skyscrapers is Bill Baker, who has done the Burj Khalifa building. He said that he made a statement when he was visiting India that to think of structural design in a design competition actually for skyscraper, they will only first consider the structural system and the economy in the design. Because if we don't provide the right structural system, the cost of the construction is going to be doubled even sometimes. So we have to also think of serviceability criteria of drift, vibration, and occupant comfort. Occupant comfort, we have seen when the first skyscraper was built, this Empire State Building, people have learned designing the window panes for wind and also to accommodate the drift and vibration during wind conditions. So a lot of codal provisions have come in for taking care of the occupant comfort. So I just shown for an idea some of the buildings in Hyderabad, the residential on the right side and office on the left side, high-rise building or tall buildings. We can call them tall buildings actually. Beyond 30 meters, any building is a tall building. And as per our 16700, any building that is more than 50 meters and up to 150 meters is a tall building. And so just let us look at the skyscrapers and tall buildings across the world. And when we talk about skyscraper, Burj Khalifa comes first actually. And for me also, I visited this during construction itself about 3 times, starting from foundation to finishing. It is so fascinating to see the concept of structural system, construction methodology, and the time in which the building is completed within the timeline. So the construction methodology and the structural system buildability aspect all covered best in this building. And we can still call it the best skyscraper and tallest skyscraper as of today. Just yesterday or day before only, I have seen Saudi Arabia building is just crossing this Burj Khalifa height now. So maybe till completion, we have to wait for it to be called the world's tallest. So Burj Khalifa is the best tallest building in the world in structural efficiency, in structural concept. And also, in fact, Bill Baker, when he was interviewed in India, he made a very interesting statement for a common man. How do you design this kind of skyscraper because of the wind? He said, we confuse the wind. That is the statement he made. In fact, technically speaking, this has that, if you see the staggered projections, if you see spiraling, what we use streaks in the chimneys for creating turbulence in the wind, so that once you create turbulence in the wind effect or forces due to wind on the structure will be reduced. So that's what he has done in this. And also another interesting thing about Burj Khalifa was they did not declare the height of building until foundation work has started piling. And till then, it was only, this is from Bill Baker only information. And they have only given height of building as 500 meters. And they have designed the foundation for 500 meters. And after casting of the foundation piles, they have revealed the height to be 829.8 meters. So how do you accommodate that kind of additional force in the foundation? Then what they did is they have just rotated the building. If you see the shape in a Y shape, they rotated the building by 60 degrees so that the drag effect on the building is reduced to half actually. So because of that, they could accommodate the same foundation what is given for 500 meters for this 820. That is the beauty of structural engineering. That is the beauty of confusing the wind actually. So this is about Burj Khalifa, the information that I have collected from the designer himself. Next, high-rise. There are many high-rise buildings. In fact, Merdeka, Kuala Lumpur comes next, second tallest after Burj Khalifa. And we have the Shanghai Tower in China, very interesting shapes. In fact, these are not the fascinating shapes of architect, actually. These are the shapes arrived at to optimize the loads in the building. Every shape has a purpose for minimizing the wind effects on these skyscrapers. So I'm not going to the details of each of these. We'll cover the main topic of our high-rise happening in India. But for us to get motivated from what is already existing in the world, I thought I must share this. So these are all the buildings, Bly Street, and then Signature Tower, Jakarta, also 111 stories, 638 meters. So, and Singapore buildings, you can see Tower in Manila, Philippines. And now there's just some of the examples. I'll share more as we move forward. And need for high-rise buildings is optimize the land use in densely populated areas. If you come to Hyderabad, nowadays, in fact, Hyderabad has the better master planning, actually. They have identified certain pockets which are called as the skyscraper zones. So they have encouraged builders to construct skyscrapers. And now Hyderabad is having 60-story buildings and crossing more than that. And the advantage is they have provided the corridor for infrastructure, whether it is approach roads, power, water, drainage, stormwater, all these are very important. Before, I mean, structural system definitely is important, but before the structural system stage comes, we should also think of all these utilities. And one Singapore funder told me, any FAR more than 7 will put a lot of stress on the infrastructure, that is the utilities. So it's very important to think of these things as engineers for us to encourage or propose this kind of skyscrapers or high-rise building. it definitely reduces the urban sprawl. Otherwise, you know that if the density, unless we increase the density of population, the distance of travel keeps growing. So we have to optimize this density of population with the high-rise and allowing the skyscrapers in certain pockets. And it also increases the space efficiency and reduces the overall cost, life cycle cost actually. And it provides better infrastructure and urban aesthetics and the city skyline and economic growth and development. If you see any, if we think of Shanghai, for example, it has the highest skyscraper density, and similarly New York. So we can see the economic index of these cities by seeing the number of skyscrapers. Of course, Singapore and Hong Kong had to go for these skyscrapers or high-rise because of the density of population, because of the limitation in the availability of the land. But China and India, Mumbai, if we see, we have the maximum skyscrapers. So it indicates the economic growth in that region. And it also has to meet we know that the residential and office and commercial activities are complementing each other. If you have office space, then there is employment. If you have employment, there is need for residential. So this is and if you have these two, commercial or social infrastructure is very important, like institutional, hospital, all these come around these two actually, office and residential. So we have to think of these high-rise building wherever the density of population increases. So finally, if you need for high-rise buildings is for efficient land utilization and rapid urbanization and population growth, insist on high-rise buildings implementation, and then economic development and land value optimization also. It is very important. Reduction of urban sprawl, as I mentioned, optimal use of urban infrastructure, and advancement in structural and construction technology also will drive this growth of high-rise buildings. We have seen after implementation, almost like 20 years, last 20 years, we have been implementing the what you call MI1 or rigid monolithic construction. With that technology, the implementation and the buildability of high-rise buildings has become quite handy actually, for engineers, for the contractors, for the developers, and for the builders. So improved living and working conditions because of the compactness. Suppose you have 2 lakh square feet per acre, which will drive about 1,000 people living in an acre. And we are doing a project in 100 acres in Hyderabad, where the expected density of population is about 50,000 people. That means 500 people per acre on an average in 100 acres is quite high. And the sustainability and environmental benefits and development of urban skyline and city identity, mixed use and vertical city concept. We have seen in already developed countries where you have single building which acts as a city. So we are also moving towards that actually, so that you reduce the mobility requirement and you have everything, bank or educational institution or hospital within the same vicinity, so that people can walk to any need actually. So functional planning considerations, we all know the individual dwelling units, detached, dual occupancy, and low-rise buildings, G+2 kind of thing, and 3-story, 4 to 6-story. Finally, 7 floors and above comes under high-rise category. So from where all these today's topics that we cover will be gain more importance because the cost of construction, the technology that we use, time required for construction, all will affect the implementation of this project. So for planning consideration, I'll slightly cover this aspect because it's very important for all of us. Building use and zoning. The zoning of the that is development control regulations. We have to study that before even proposing this because that covers the aspects of social infrastructure availability, and basic education, healthcare, all these things. And next comes important floor planning in high-rise. As we all know, as the height of the building increases, the service core percentage will keep growing. Normally, it comes in 20%, the connectivity within the building plan. So it grows up to 50%, 60% even, the core requirement. So the core planning and the core location also is very important. Vertical transportation, whether it is elevators or escalator, and speed of elevator, number of elevators, capacity of the elevator. We all must know that there is a software available for designing the vertical transportation, depending on the number of stops and the type of stops that we propose, and the population and the time zones of the population movement, whether it is a working population or whether it is a retired population. So that we have to consider and design the vertical transportation. And the circulation and movement, we have to make it very efficient. In fact, in the planning, we have to see that the circulation area is minimized and maximize the carpet area in the planning. Fire and life safety, this is very, very important. We all know when this World Trade Center was attacked and it was subjected to fire, the fire safety efficiency was at its best, actually. When there were 50,000 people in the building, within 1 hour, they could evacuate 47,500. Only 2,500 lost lives in that. So for a 100-story building. So it's very, very important, life safety and fire safety, whenever we start planning. In fact, in the projects that we work on, the first thing is to think of the fire safety and decide the number of cores that are required for evacuation and travel distance of every person. They're all given in the National Building Code. So we have to study the National Building Code in detail about all these requirements, whether it is circulation and movement, vertical transportation, fire and life safety, and most important is lighting and ventilation. We have to see that whatever planning that is done will provide natural light and ventilation. We all now are talking about green building, and for the green buildings, we have to put our effort to see that natural light and ventilation are provided. Minimum abutting road width, as I mentioned, and traffic analysis. So we do this in all the high-rise buildings, the traffic analysis and the adequacy of the road width and number of lanes of connecting to the building. Setbacks, that is the open space around the building. That is very, very important for any high-rise building. Minimum open space required is 7 meters all around the building. That is for the movement of the fire engine and evacuation of the people. And internal transport within the campus also, and corridors and service ducts. You know, when they have done the first, yesterday or day before, I was reading about LIC building in Chennai, which was the first high-rise building in India, 10-storied building. But it was subjected to fire accident in 1975. Then they realized that the ducts which are provided for the services, whether it is for plumbing or electrical, these ducts carry the fire to upper floors, actually, because they connect all and staircases. So because of this, the fire norms have changed. We have to plug a duct at every floor level. So these are all very important safety aspects. And fire escape staircase and travel distance, as I mentioned, fire escape staircase we provide in high-rise building, pressurized shafts beyond 30 meters. We have to provide a pressurized staircase and pressurized lift so that people can escape through that pressurized staircase and lift without being affected by smoke. And the service floors is another requirement beyond 10 floors. If you have a high-rise building, we have to think of service floors, particularly above 20 floors, actually. We must provide service floor that is for the sake of fire, for the sake of water, for the sake of waste management, and for the sake of this relief areas. And then waste handling and green space index. That is very, very important. In Singapore, it has become a compulsory thing to be followed. green space index. That means if you are constructing a building in 1 acre, if you provide a greenery over an area of 4,000, then your green space index is 1:1. So we have to think of this green space index also when we are densifying the areas with population. Now, for us, the most important structural systems for the high-rise buildings. Let us see the structural systems of the available building, already constructed buildings. And before that, let us understand what is moment resisting frame. That is the very basic system. For up to 7 floors or 10 floors, we can have just moment resisting frames. And then beyond 10 floors, we must have shear wall systems. We'll add the shear wall. And then we also have dual systems. That is combination of shear wall and frame. When I say shear wall, nowadays, the MI1 or rigid monolithic construction is with the complete shear wall system. And next is the tubed frames or outrigger systems. So these are further advancement. In fact, Fazlur Khan from Bangladesh, he is the first one to introduce these tubed frames. He is inspired from the bamboo, because bamboo tree is the natural tallest structure actually. Tall in the sense slenderness, from the slenderness ratio, height to minimum dimension. So he is inspired from that natural structure and then devised these tubed frames. And in Chicago, the first tubed frame, Sears Towers, it was the tallest in those days, and during 1970s, about 50 years back. And then the tubed frames have, after that, further advancements have come with the outrigger systems and buttressed core and all that. Let us examine these systems. You can see in the picture the shear wall and the frame combination. And on the right side, you can see the cores and the shear wall combined with the frame also. And beam column frame action and resist gravity and lateral loads, moment resting frame, and suitable for low to medium heights. As I mentioned, anything from 3 floors to even 10 floors, we can go for this moment resting frames. And as structural engineers and civil engineers, we must know that the basic things, whether it is high-rise building or normal building, tension, compression, shear, bending, and torsion. These are the forces for which we have to think of designing and resisting using these capacities of the elements. So we should know which elements are good in resisting what? Tension, compression, shear, bending, and torsion. So we have this shear truss, shear wall, core supported outrigger system, and combination of these systems. And so I'll show you some of the drawing. Moment frames on the left, you can see braced frame, then comes the shear wall. So in shear walls, we can also model as braced frames when we do the analysis. And now let us look at the worldwide, what are all implemented. Like we have the braced hinged frames, we have rigid frames and rigid frames in steel. We have concrete shear wall and steel hinged frame. And we have braced rigid frames, concrete shear wall with steel rigid frame, concrete shear wall and concrete frame, and outrigger structure. That means we have the central core connected with the rigid diaphragm to the outer frame. So that is called the outrigger structure. So now laterally supported vertical steel trusses in shear trusses and resist the lateral loads, but main lateral loads are wind and seismic. And then braced frames, we have concentric braced frames and eccentric braced frame. And so for mainly, let us understand whatever structural system we are talking about is finally to dissipate the energy. And we can dissipate the energy with a little bit of flexibility in the structure rather than total rigidity, actually. That is the ductility we are talking about. So that's why we use steel also in the structural system, because steel is very good in ductility, but it has 2 disadvantages of fire resistance and corrosion problem. and effective in the shear stresses are effective in resisting lateral load and can be designed for high stiffness ductility depending on the type of the frame. Then coupled shear walls, and so the walls, two shear walls coupled with the beam connection will help. In a beam we have tension zone, compression zone. So similarly, a shear wall also, which is a very rigid thing. If you have two shear walls on the windward side and leeward side, then it acts as a beam with the coupling as a shear connectors to these two stiff shear walls. Basically, shear wall is a plane stress element, and they share the loads and resist lateral forces together, and improved structural performance under lateral loads, particularly wind and earthquake. So let us look at this structural system like a braced frame and shear wall with base isolation. So this is the basic structural system for any earthquake resistant design or wind resistant design. For earthquake only, we need the base isolation. For the wind, we need these bracings, which will be very effective, and shear walls in transferring the loads. So now let us look at the rigid frame construction, that is rigid monolithic construction nowadays, which is quite prevalent in almost all the high-rise buildings and tall buildings. Is the norm. This has become a norm. So we have to understand the structural system of this, and that's the name itself indicates it's a rigid monolithic construction. And the advantage is by the time we complete the structure, we also have completed the shell. That means walls, internal walls, and all that. But the only major thing is we as structural engineers have to insist on having shear wall continued up to the foundation. In this picture, you can see in the bottom there are columns and the so-called transfer slab. We have to discourage as structural engineers because in performance, it's not very good, and cost or effectiveness also it is very less, because we are not utilizing such a long shear wall from the top to almost parking level. And in the parking level, we are terminating the shear wall. So we are not transferring the complete stresses to the foundation, and we are again creating a transfer slab which will transfer the forces from the shear wall to the columns, and columns are like soft story again. So this is very, very important. We have to keep in mind that we should go for shear walls through. And many people say that architects resist this, but I feel that what to build developer or architect needs is to plan for the parking. So give a plan. In the shear walls, we can give openings and give the driveways through shear walls. We have done some projects, not some projects, many projects where we have continued these shear walls and derived the advantage of structural efficiency. Next, they're designed to resist vertical loads as well as the lateral loads. And if there is any bad structural system, this is what is going to happen, the failures without proper jointing and without proper transfer medium. So let us understand the shear wall classification. Simple rectangular type, coupled shear wall, and rigid frame, and framed structure with shear wall, and column supported shear wall. This is what is I was telling, not very good. And core type. You know, any building requires staircase and lifts, and they are very good to implement with a concrete wall, and particularly pressurized staircase and pressurized lift. Then you can have a core type, and core you can connect. So that's how this buttressed core concept comes, and you can have the shear walls buttressing the core, and that's what. So these are all the RCC shear walls. As I'm showing, you have to preferably take the shear wall down to the foundation. Shear wall frame interaction systems, and so these are all the buildings. I mean, the good part about it is we are now almost crossing 100 years and 125 years of these tall high-rise buildings, which are constructed in concrete actually. So we can study this behavior efficiency, how they have done. more than a century old buildings. So these are all the buildings that are exist. And so these are all the structural systems of the braced frame and wall frames and core system. I'll just quickly show you these structural systems of some of the existing buildings, hybrid structure and structural systems. So these are all the structural systems and Chicago rigid frames structure. And this is the interaction of, you can see Park and Paul, a book in which these figures explain about how the theory behind this is explained very in detail. I'm not going into the theory part. I am only covering the planning and design aspects, but we should understand how the lateral force is shared between dual systems like a frame and shear wall. And outrigger system, this is a very, very interesting concept. Outrigger system reduces the base moment drastically, almost like 50% or by 40%. So this is the braced outrigger system. So outrigger is like a belt system, actually. You create one floor as a belt after every 10 floors. That becomes an outrigger. Connected to the central core, then it will reduce the moment, base moment, as I have shown in the right side. So this is a very good example of outrigger system in Taipei. So Taipei Tower, it's 101 stories. You can see the structure itself, and it gives aesthetics also. Any good structural system will give aesthetics to the structure, like a well-built man being handsome. So well-built structure will be always aesthetic. So we have this concrete frame tube in the left from 30 floors onwards. We will be normally going for a frame tube and steel frame tubes. You have tube in tube, not very efficient tube in tube, but tube in tube with with the buttressing will act better actually. And the concrete braced tubes and steel braced tubes, steel dag grid. Dag grid is very, very efficient in some cases. In fact, we have done a pyramid structure of 50 meters high, where this dag grid has saved the structural consumption by 40% reduction because of the dag grid. So dag grid is very efficient in some of the shapes and requirements. And similarly, exoskeleton is another, I'll show you some of the existing buildings in these structural. Super frame is another very interesting concept which was used in World Trade Center. Of course, it's not existing now. So these are all the frame tube. That means outer core is designed to resist the lateral loads, and the inner core is designed to resist only vertical loads. So, but shear lag is the major challenge in these frame tubes, because corner forces, the theoretical shear versus actual stress will be a lot of difference. So we have to be very careful in using this kind of structural system. Ion center is a frame tube, and then braced tube systems. We can see the load path and braced frame. And these are John Hancock Center is in Chicago. You see a lot of these frame tubes in Chicago because Fazlur Khan was from Chicago, and there is a Fazlur Khan Foundation actually encouraging more innovation in this. And so he can see the bundled tube, like as I mentioned, this bamboo structure. You never see single bamboo standing, there will be, so that's where again bundled tube concept has come. And bundled tube, again, to reduce the wind, to confuse the wind, you can see the staggering of these bundles, actually, tubes. So this also resembles the outrigger system, clubbing these 4 tubes. So you can see how the tube will be staggered in heights in the outer periphery. That will reduce the wind due to the spiraling effect. So this is the bundle tube theoretical thing, and the stresses you can see. And this is the Willis Tower, which is very good bundle tube example. Next is tube in tube. This is the West Madison Street, Chicago, 50-story building with a tube in tube system. and diagrid system. So this is one of the examples. This is not a real high-rise in, as I mentioned, different shapes only diagrid will be efficient. Super frame, as I mentioned, is not existing now, but this was one of the best structures constructed in steel. And space truss, China, Bank of China is a very interesting structural system with aesthetics and exoskeleton. This is a hotel deal last in Spain. Actually, you can see how beautiful it is with the bracings, and structure itself becomes the facade-like thing. And it's for a hotel, always facade is very important. People connect to the hotel with the facade actually. Next is the buttressed core, the latest and best that we have seen, Burj Khalifa, very efficient. When I visited this structure in the basement, the column size, minimum dimension is 500 mm for such a 828 meters tall. So next, let us come to dynamic analysis and effect of wind on high-rise buildings, because wind governs the structural efficiency. And effect of wind load, we know that there are effects of wind, drag effects and dynamic effects. So we have to see, you can see how the leeward side, there will be drag effect. So shear, moment, and deflection. These are the three things we have to study. So static effects and dynamic effects. So these are all the how the wind hits the building. I'll show you some. Yeah, these are the wind tunnel studies. Yeah, in fact, for Burj Khalifa, when they have reoriented the building, they have again studied the wind tunnel effect, and they found actual reactions were reduced because of the orientation. These are the wind tunnel experiment, and you can see how the wind affects the high-rise building. This is the digital model of this wind effect. And if you have two high-rise buildings, again, how it is having, you can see. And the multiple, like New York City, you have the multiple building and how the wind flow affects. So we should understand that we can never take the effect of drag on a single building. That's why any high-rise building beyond 50 meters, it is better to recommend the wind tunnel studies to understand the real effect. The codal provisions give you calculation of the drag effects, but don't go by just theoretical and analytical calculation. Go for this wind tunnel studies and understand the wind. So this is how the wind is simulated in the wind tunnel. Next is the earthquake. For earthquake also, we have these shake table labs in Bangalore in CPRI, and in Delhi also, I think. I don't remember exactly. There are two Roorkee, I think. Yeah. So we have to do the model studies. We can only do the model studies, whether it is wind tunnel or shake table. We can do the model studies. And wind predominant and earthquake predominant. When earthquake predominance is there, we have to go for the base isolation. So this is the earthquake accelerogram. We always design for earthquake using the accelerogram. And inertial forces and acceleration and story drift in the analysis. So these are all the things, and we have to check the story drift, because this affects the design of windows, doors, and facade actually. So even for the sake of facade, we have to do the wind tunnel studies. And P delta effects, that is secondary analysis, nonlinear analysis, and also the dynamic analysis to do for all these buildings. So high-rise structures, I'll just show you some study that we have done in our office. Normally people tend to use plate element when doing the analysis. So what I have done is, I have done three for the same building. I have modeled three types. One is with the plate element, and so this is the stress diagram with the plate element in the type of shear wall, and then we have also used equivalent frame, like we have used column and beam system. And we studied the mode shapes for the same structure. These are the mode shapes. And we have studied column, plate element, and equivalent braced. Equivalent braced, or you should also study with the plane stress element. And these are for the same structure, same load, you can see the variation in the PU max. When we are using the beam column and equivalent braced, we are getting the higher axial load. You can see the variation is almost like 12% from the plate. When you use the plate element, you will underestimate the axial loads by almost 12%. So we have to be very careful when we are modeling this high-rise building in usage of the right element in the finite element or STAD analysis. And movement, if you see, sorry, the spelling is wrong. Movement, it's not movement, it is movement. Movement in the plate element is higher because plate element is basically a movement element. It's a flexural element. And then beam column comes the next, and then shear truss, that is braced column bracing system gives the least moment. So next is the shear. And variation in the shear force, if you see beam column gives the lesser shear force, and the braced frame gives more reasonable, and plate element gives the higher shear force. So the conclusion is better to use for the shear walls, use the plane stress elements, basically. And the base isolation system testing and acceptance. So you can see with the isolation and without isolation, how much of the drift is there. In fact, we have done some of the buildings, if not high-rise, using base isolation is very effective, actually. Next is the planning and construction management of this high-rise building, time management, quality management, very, very important, building information modeling, and risk at construction management, that is controlling the cost, controlling the time. So this is very, very important. So I'll briefly touch upon this construction aspect. So the formwork, engineered formwork is very, very important, and safety during construction is also very important with the platforms, railings, and all that. So auto climbing formwork is the very efficient system for the core and shear walls, actually. We can use this auto climbing formwork. Next, the rebar fabrication, the accuracy in the rebar placement and tying also is very important. So we have to use the prefabricated rebar, which will be very good in quality. Next is the concrete pumping. We have seen Burj Khalifa, Germans have designed a special pump for pumping concrete up to 500-meter height. And in Hyderabad also, when we did the first tall building, we had to get a special pump from the ready-mix vendor. And next is the drop head systems for reducing the cycle time of this centering and formwork. And the major equipment used is tower cranes, we all know. And now we have these rope suspended platforms, which is, and also builders hoists or passenger hoists or multi-purpose hoists that we are using in high-rise construction. So reduced construction time, sustainable development, and cost savings is in using these construction method. And plumbing and electrical, firefighting, finishes, windows and doors design, and building envelope panels, factory fitted insulation and cladding, and it can be load bearing also, and factory quality, accuracy, and so this is the precast flat panel system. So we have also done precast construction in Hyderabad, where we have done up to 11 floors, but my group has done up to 50 floors. So in precast, 3D volumetric is also coming up, and tunnel form for high-rise residential. And we have this rigid monolithic construction and flat slab systems with the table form we can do for office building, and hybrid concrete construction that is using precast and cast in situ rigid monolithic. That also we are doing some of the projects, and precast foundations, pre-stressed concrete in hollow core, and disorganized site versus organized site. So we have to insist on organized construction in high-rise building. And safety measures is very, very important during construction. And safety, fire rating of the walls and various elements, columns and all, we have to take care of the cover in the design. And so fire safety is a very, very important subject. I'll not go into the detail, but we should be aware that we have to think of these things. So I'll just show you quickly some of the projects that we have done. This is the first tall building in Hyderabad. After this, many have come, but before this, the highest building was 15th floor. This we have done 30 floor. And this is a buttressed system. Even before knowing about buttressed core of Burj Khalifa, I have modeled, designed as a buttressed core system. So these are all the plans of this building with a podium and 2 towers. And this is another project that we have done with rigid monolithic construction. And this is also, we have done active retirement homes, many, almost like 5 million square feet. It is a combination of shear wall and frame. So right now also some of the, this is a commercial building in Hyderabad. We have done expansion joints and earthquake safety modeling, sacrificial slab also we have used in this. And because of the time lapse, I'm not spending much time, but these are all interesting aspects. Now the ongoing projects for us is in Hyderabad. We are doing construction management for this, and we are also doing in Mumbai. Thane, we are doing for high-rise 36-story building, residential, and this is ongoing construction. And for my home, we are independent engineers for this 26 million square feet in Hyderabad. And this is a completed project, 20-story building completed in 20 months with the gold rating of Gruha. So these are all the projects that we have done, completed. And so I think I'll try to conclude now so that we can have some time. This I'll not cover today because time is not enough for this. And, so finally, we have come to the end of the session. And this is available on YouTube. You can also refer to YouTube channel. The same topic is available on my channel in Ponnada Surya Prakash. And you can also mail to me or message me on my numbers. So shall I stop sharing, sir?
Yeah, excellent presentation, sir. Now already there are so many questions which have come. So okay. I think let us take the questions one by one.
Yeah.
And before we start with the presentation, it was an awesome presentation, and almost all the aspects of real estate planning, design, safety, and structural configurations, construction, everything probably you have touched upon. So which is very difficult to cover in 45 minutes or 1 hour time. So first question which is coming up is, what are the biggest fire safety challenges in high-rise building and how they are addressed? This is asked by Professor Surya.
Okay. Yeah, that's a very good question. We have seen the recent accident in Hong Kong. You know, the fire safety requires the minimum distance between tower to tower. And preferably half the height of the building is prescribed. But in most of the Indian cities also, we are limiting the block-to-block distance to 9 meters or 11 meters kind of distance. So in fire, Hong Kong, what happened is the fire has spread from one tower to the other because of the lack of the minimum distance between these towers. So it is, and you know, now in India, we are going through the worst period as regards to safety regulation. National Building Code, the government of India is trying to deregulate, which we are all trying to resist and oppose. I mean, let us wait and see what God decides finally. So fire safety is very, very important. We have to follow the National Building Code guideline. there are many fire safety norms available in our country for defense project, for explosive projects, for industrial projects, and for normal real estate projects like residential, office, and commercial. So we have to follow these norms.
Okay, great. There's a next question coming up from Mr. KC Ghali. He is asking how we distribute shear in a building.
Oh, that's a very good question. As we all know that shear is concentrated in not in the outer periphery, it is in the central portion. That's why we have the shear cores in the buildings in the central portion. And from planning point of view also, the lift staircase are preferably in the center of the building, and that naturally helps in, but that the shear has to be connected, as I said, outrigger system or tube-in-tube system, as I mentioned, we have to connect like stirrups, in a beam, reinforcement stirrups, which will distribute the shear. So same way, we have to connect the central core to the outer core with a shear wall again. So that is the best way to distribute the shear from the central core to the outer, actually. And bracing is another option. Bracing is a very efficient element when the height is less. 10 floors or 12 floors, we can also use the braced frames.
Okay, great, great. So you mean to say that there is no single, mantra for it? As per case to case, you can have different solutions.
That's why, that's why we have seen so many structural systems already developed, and for every shape of the building, we have to devise and implement most optimal structural system. That's why we need to understand all these structural systems before we come up with a new structural system, which can be a hybrid also of these systems.
So every building is a new project.
Yeah, exactly. Every tall building is unique by itself, actually, from its plan, from its shape, from its form, all these things.
Okay. There's a next question, slightly longer one, asked by Mr. Sandeep Gade. He's asking, what are the key differences between the design of a conventional building and a tall building? That is part one. How does site-specific conditions, evolving code requirements, and the client-driven performance expectations influencing the tall building? Then he is asking, additionally, what are the common pain points faced by the young engineers, and how can we study in early career of the profession?
Very good. So I'll divide into three questions as asked. First question is difference between the conventional building and tall building. That is the major thing. A conventional means I understand up to 5 floors. That is the very simple conventional building where we by default go for a column beam system. And when it comes to a tall building, as I mentioned, the shear walls will come in, the core, central core will come into picture, and connecting the shear walls, core, and the frame. That we have to plan very carefully right from the planning stage itself. I'm tempted to mention about an example. I have done a project. I have shown that Saket 30-story, first 30-story building in Hyderabad, where I insisted on the architect to allow shear wall to be taken into the parking, because of which we could arrive at a steel consumption index of 3.4 kg per square feet. Whereas for the same client in Bangalore, when we did the project of 16 floors, where I was not allowed to take the shear wall to parking levels, where the wind is less. We all know Bangalore is 33 meters per second, Hyderabad is 44 meters per second, almost 30% higher, and in Hyderabad, and floor height also is half. So by any means, it has to be, actually steel consumption has to be much less compared to this. But in 16-story structure, because we are not allowed to take the shear wall down, we had to spend double the steel quantity. So because of the transfer girders and transfer slab kind of system. So that's why we as engineers should oppose or educate the developer about this nuance and see that we use the efficient structural system. So as the building height increases, tall building structural systems plays greater role than the nice planning or aesthetics actually. So that is the first question. And code requirements. This is a very, very interesting question in the building design. We are very insensitive to code actually, our country particularly. I have seen two examples, one in Singapore and the other is in Japan. I was chairing sessions on those Japanese presenters giving talk on earthquake retrofitting after Kobe earthquake, you know. We all know that the Kobe earthquake has opened eyes on seismic design by introducing vertical acceleration actually. In the entire country post Kobe earthquake in Japan, they have retrofitted all the buildings. That is when the concept of damping, viscous dampers, brace dampers, all have come into picture, and they have implemented 5-6 different methods of damping by retrofitting the existing buildings for the vertical acceleration. In India, we are seeing already in the last 30 years, we have 3 revisions in the code, IS 1893, including the latest. But how many of us are educating the public about the need for retrofitting these buildings? In fact, some people are even questioning the veracity or need for increasing the cost of the building. Even our own professionals are doing, which is not correct actually. We are all part of the revision. So we have to respect the revision and we have to educate the people about the need for this rather than crying after the disaster actually. So this is for the second question. We have to be very sensitive to these codal provisions and changes that are happening. Number 3 is what are the common pain points faced by young engineers? There are many common pain points, young engineers. Actually, the first challenge about young engineers is the reach to the best teaching people actually. So I'll come from there actually. The teachers, I'm not complaining against anyone. This is the system that is happening. This evolution that is happening. We are, as a society, we are not respecting the academicians. So, and we are not honoring the academicians with the right pay or respectable pay actually. So because of that, we are getting those who are not able to get any other livelihood, they're getting into teaching profession. And so we can imagine young engineers, how they'll be affected because of the low quality teachers actually. That is the first thing. There are good quality, there are exceptions actually in both the cases, but I feel that by and large, most of that, I have come across teachers being, lecturers in engineering being paid some 12,000 rupees per month, which is a postgraduate. They want to be in their village, so they want to earn whatever is possible. But you can imagine the quality of teaching there. So we have to, that is why you have mentioned, I started a trust called Smart Infra, and where we try to help young engineers with ability and employment. There is underemployment, there is lack of employment, and there is very underpaid people actually. So this we have to fight as professionals altogether.
Great. Yeah, there is another question coming up by Mr. Sandeep again. Is there any condition when the code drift limit is satisfied, but the motion is still felt? So
yeah, there is a limit on the acceleration actually, acceptable acceleration. And in fact, there is a codal provision for acceptance criteria for this acceleration. It is better we refer to that. And so based on that, we have to limit the drift or acceleration.
Yeah, there is a next question by Engineer Ashok Kumar. He is asking, please highlight some introduction of Mivan structure and comparison of structural performance in comparison with the other structural system.
Yeah, my one is a very widely used system, as I mentioned, and you can also refer to my YouTube lecture on this rigid monolithic construction. I have detailed there about this structural system, and it is more rigid actually. In fact, in IS 16700, there is even a blanket statement not to use this system in tall buildings. Actually, that is not correct. Actually, we have to go to the preamble and see. The engineer has to take a judicious decision while deciding the structural system. Actually, we have to introduce. We have to analyze with the complete proper model and design. Uh, Introduction has happened, as I mentioned, about 20 years back in India. It started in Bangalore with the Brigade Metropolis project, 20-story building completed in 12 months, I think. It's very effectively used, and after that, it spread to many projects in all the cities. And I have used, first private project in Hyderabad, this my one system for a 5-story building also. There are many success stories, and structural performance is very good. In fact, using rigid monolithic construction helps solving many problems in the structural system.
Okay, great. Yeah, there is another question coming up from Ms. Madhu. Sir, based on what criteria building is named as high-rise building other than 50-meter limitation as per code, as the height varies from place to place?
No. Actually, we have to have some norm in terms of 15 meters to 50 meters. We can treat it as high rise, and 50 to 150 as a tall. In India only, I'm talking about in India. Where, as mentioned, different countries have different norm. But in India, we will limit our discussion to Indian code. And beyond 150, it is a skyscraper actually.
Okay. Yeah, there is another question coming up from Engineer Mangesh Kulkarni. He is asking, as a student of UG, what books, research papers can I refer on shear wall design?
I'm sorry, actually, I'm not able to immediately help you with the answer. I'll definitely answer this later.
Yeah, sir, there are a couple of more questions regarding, books which are to be referred. So what we can do is you can compile.
No. I'll give a general or generic answer for all the students. If you want to be a good structural engineer, I'll mention that. I mentioned it in my YouTube also. The best books for understanding the structural systems are Timoshenko, Theory of Plates and Shells, and Purushothaman, Advanced Reinforced Concrete Design, Park and Paule, Reinforced Concrete Design, S.N. Manohar for Tall Chimneys, and Ferguson for Reinforced Concrete Analysis and Design, and Bowells for understanding the soil structure interaction and soil. So these are the 6 books you have to always refer, whether you are designing a high-rise building or a normal building or a long-span building. You will have better structural concepts. In fact, we were asked to study well these books when I did my master's in structural engineering.
Oh, great,
Yeah.
great. So
I
actually,
always tell all the students.
You have pinned up some masterpieces, 6 masterpieces.
Yeah. That's right.
Yes, there is another question coming up from Engineer Puneet Surya. He's asking, from construction management perspective, if you can continue this series, more time scale, we can schedule for the upcoming season. Okay, so that suggestion.
Actually, I have one lecture in my YouTube only on construction, actually, construction system, mechanization in construction and all.
Okay. There is another question. Mr. Sudarshan is asking, concept of outrigger design as a deep beam or something else?
No, it's not a deep beam actually. I'll not call it a deep beam. Deep beam is totally different, only shear. Outrigger, what it is doing is it is redistributing the flexural stresses from weaker zone to stronger zone. So that is why the outrigger will help in redistribution of flexural forces, as I have shown, and reduces the overall movement. It is like, I don't know how many of we observe in a aeroplane wing, you have at the end a bend. In fact, that is to reduce the moment. It acts as a support actually due to the wind. So it creates a flexural support to this wing, actually freestanding wing. So same way I have done in one of the project, a folded slab, not folded plate. If you have a large span slab, if you make it a trapezoidal shape, the moments in the slab will be reduced because of the fold across the span, fold across the span. So this I have used effectively. I have designed a 11-meter span slab with a 150 thick slab.
Oh my goodness.
Yeah. Normally folded plate, fold is along the span. In a folded slab, fold is across the span. So I have utilized that. So that can be done.
Great. Yeah, there is another question coming up from Engineer Singh. There are two questions. Sir, can you please share some name of the softwares for high-rise buildings and also wind tunnel analysis? And question two says, what are the safety measures we can take during the construction of high-rise buildings in case of earthquake or emergencies?
Oh, that's a very, second question is tough actually. First question I'll answer first. Actually, the analysis software that we use, particularly for this rigid monolithic construction and shear wall, is ETAPS. We all know ETAPS is a better software when it comes to modeling the wall. And STAD also can be used with but proper elements to be modeled. And wind tunnel analysis, we have to go for boundary element analysis. We have to use any finite element software like SAP, ANSYS. I don't recommend using the software for wind tunnel effects. It is better to go for experimental internal studies. We have in India also now a Trivandrum-based company, RWI is a company who will help us. Dr. Suresh. And safety measures, I have seen the best safety measures in London, actually, when I visited during construction one of the high-rise building. In fact, the railings, safety railings, fall arrest safety net system, they're all very important. I have a lecture on safety in a high-rise building. In my YouTube, you can refer to that for safety particularly.
Okay, great.
Yeah.
Great. There's a next question coming up from Engineer Parameshwar Prajapati. He was a student of IIT Jammu and now he's working with ISSE India. He's asking, sir, what is a parameter to be deciding for the expansion joint and the location of expansion joint, size and its type?
Very interesting question. Expansion joint we provide for temperature effects basically. And I have come across some people asking in a 50-meter building also asking me to provide expansion joint. When the building shape is regular, that is a typical rectangular or square kind of shape, there is no need to provide expansion joint even for 50-meter because code says 42 meters somebody refers to. It is always better we do the temperature analysis, and if we are not able to design for the stresses due to temperature, then introduce. But in odd-shaped buildings, instead of calling it a expansion joint, we'll call it a separation joint. And we'll provide the separation joint to wherever the shape changes drastically, so that the torsional effects due to wind or earthquake can be minimized. And that's what I have shown in one of the projects we did. We have calculated the drift due to earthquake or wind, and we have provided that much gap, and we have provided a sacrificial slab in that joint. Suppose we have provided 1 meter gap, and we have provided just 75 thick slab. So in case of real earthquake, that slab will fail, and it will save the slab actually. It is a weak link actually. So that is the concept we can adopt in joints actually.
Excellent, excellent. There is another question coming up from Engineer Shirish Patil. should we adjust the stiffness of the building such that matches approximately time period of 0.1 n? So we get good results in reinforcement in the section sizes.
Yeah, that's the way we have to work actually. We have to play with the stiffness. In fact, I have done, I also do transmission tower design. There are cases where we have changed the initial stiffness of the members so that we achieve the target force in the members.
Oh,
So we engineers have to play with stiffness in
great,
the
great.
analysis.
Sir, in between, we will go with the next question. In between, one question is coming up in my mind. I had been to this Gachibowli area of Hyderabad. So many tall towers are coming up. So suppose if we do first tower where there are no other towers adjacent. Okay. And when we come up with new towers, how does it affect the wind behavior of the old tower?
That is a question I also always used to have, because you cannot think of future, how it is going to change the domain. And in fact, more towers will only reduce the force, as we know. Surrounding buildings, we have the drag coefficient, K2 factor in ISSE 875, which reduces with the category 4 actually. That is
Okay.
all high-rise building. So we need not worry much about it, but definitely we have to do the modeling. We may have to, suppose there is a drastic change after construction of 10 years. So we have to recommend to the client to do the wind tunnel study again and see if any retrofitting is required for specific elements or specific zones. That has to be done.
Okay. Yeah, there's the next question by Engineer Sudarshan. He is asking for high-rise building, how expansion joints are provided. Is code limiting 45 meters only?
Yeah, that's right. Actually, it is 45 meters is the normal class if you follow that. But as I mentioned, in some cases for odd shapes and all, we have to provide preferably separation joints to bring in symmetricity in the plan actually to
Okay.
avoid torsional forces.
Okay. Yeah, there is a next question coming up again from Engineer Sandeep Gade. Sir, is there a vertical high-rise limit for structural engineering point of view? Is there a technical limit to the height of the building beyond point which there is factor that will not allow to go further height of the up to sky?
So far, the engineers have thought about up to 1.6 kilometer tall building. The concepts were presented by Bill Baker only. I have attended that concept lecture also, the shape and how we can design. But beyond that, I cannot answer beyond that.
Okay. Yeah, there's a question coming up by Engineer Nachiket. In tall building, the dynamic analysis shows that the first two natural modes do not satisfy the codal requirement for transitional behavior. In certain cases, the second mode is governed by the torsional response. This leads to violation of the codal provision related to the mode shape requirement. Under such circumstances, how should the building be designed to ensure the seismic safety?
Mode shape and see. Yeah. Actually, whenever we are not able to satisfy the codal provisions in any mode shape or transition phase, that we have to modify the structural system or the stiffnesses. So, and we have to satisfy, there is no option for that. We have to satisfy the requirement of the code.
Okay, we have to satisfy the requirement of the code.
And mass, we know that we have to play with the mass also in seismic design. So sometimes we introduce the mass also, and we have to vary the stiffness structural system to satisfy these requirements. We have done it.
Okay. There's another question by Ayush Panchal. What type of damper can be used for tall building to resist the earthquake and wind both?
We have dynamic dampers. Actually, we have the actuated dampers. We have control dampers, and So there is a lot of work done in introducing the dampers and friction dampers, viscous dampers, and we have the bracings with the Teflon sheets. That is friction damper actually, and viscous damper using the fluids. Actually, we design the piston kind of viscous dampers are introduced, and even the bracings, the designed bracings with some ductility introduced in the design, in the joint, also can be used as the dampers actually. In the and the water tank, for example, or the mass dampers. We can use the mass dampers like a pendulum damper with the mass. All these are incorporated. We have to judiciously decide which is most efficient system depending on the problem we are facing with the acceleration actually.
Sir, how often do we use these dampers or isolation in India?
In India, in fact, in high-rise buildings, now people started introducing the base isolation to begin with. There are Japanese companies offering these isolation systems. And first and very efficient system is base isolation. Next comes the dampers, depending on the shape of the building and height of the building and slenderness of the building and acceleration you are getting in the structure. So based on that, we'll introduce the dampers. But I have done one complete isolated structure design for defense applications where we have used 3 types of damping at one location only in the base itself. We have done that.
Oh, great, great.
Damping from 15, acceleration from 15G to 0.6 G.
Oh, great. Earlier, sir, means 20 years back, like when we were practicing, the trend was, to go for a ductile detailing rather than using dampers and all. Because damping
ductile detailing is the base requirement. Actually, that is fundamental, actually. In any style, whether we use the dampers or not, the ductility has to be introduced in the system. Because it's a rigid frame. In a rigid frame, if you don't introduce ductile detailing, it's going to fail actually. There is no energy dissipation. So after that, next level is damping actually as the height of the building increases.
Yeah, there are a few more questions, not in this chat box, in a WhatsApp chat box, which have come. Mr. Murali is asking, my question is, current tallest structure in the world is Burj Khalifa with 829 meters. Probably one more is coming up, which is more than this. Yeah. Is there any vertical high-rise limit for the structural engineering point of view? I think you have already answered this question.
Yeah, I already answered.
Yeah, then there is another question by Engineer Bhavesh. Can we brief the role of slenderness in the high-rise building? How we fixed their limit?
Yeah, we have seen the slenderest structure in that is constructed of late actually. The slenderness limits is we know h by 10. Beyond h by 10, it will sorry h by 5. Beyond h by 5, there will be nonlinear effects. We have to compulsorily do the studies of nonlinear. I cannot say there is any limit like that. You cannot have h by 1, sorry, h by 10 base or h by 20 base. We cannot say that. But whenever we go beyond h by 5, we have to have the nonlinear studies. Secondary effects will play a greater role in the design.
Yeah. There is another question by Engineer Priyansh. He is asking, which type of analysis method is preferred for a G+11 RCC building to know the wind analysis in different shapes of the building, and which things to be considered during the design and analysis?
So I always suggest for the students particularly, we have the portal method, we have the cantilever method. We have to use these methods for lateral load analysis and better do that first. Even Bill Baker said they have done even Burj Khalifa, they have done the first design using classical methods only. Oh. Even for the tallest building, yeah. And then you counter check with these analysis, finite element or stiffness method. You counter check with that for very specific zones actually. For that. But in the main structural forces, there is not much of variation beyond 5% with these methods, classical methods actually.
Classical methods.
So we all should not leave the classical method. Before sitting on the computer, first be as an engineer, first you should know what is the maximum flexural force, what is the maximum shear force, what is the axial force, you should estimate and then counter check with the results.
Great. Yeah, please mute your mic. I think a few of the participants are. Yeah. Yeah, there is another question by Dr. Jagananda Rao. The question is, when there are number of buildings also, there is a tunneling effect. So please comment.
Yeah, that's what I have already shown the analytical model of that digital model of that tunneling effect. And then we have to study the wind tunnel effects in the buildings particularly.
Yeah, and I think Mr. Singh has asked a question regarding high-rise building code. So there is a code, sir, code available for high-rise building for all irrespective of the terrain.
Yeah, 16700 is the tall building code. Actually, that is beyond 50 meters. For high-rise, normal IS 875, 1893, and these codes are adequate. IS 456.
Then there is a new, there's a question, interesting question, high-rise building on a hillside and a high-rise building on a lakeside. What is a different approach to be followed?
Yeah, that's very, very important when we do the planning itself. When we do the building on a hillside, the K4 factor or K3 factor, we have to consider and calculate the wind forces. And there the wind tunnel model is also very important. And we have to consider the effects of that is given in IS 875. We have to calculate that. And when it comes to the lakeside, the important thing is the soil structure interaction, because there will be huge variation of the soil properties with the distance from the lake actually. That the permeability studies and the saturation studies we have to do in the soil. Soil investigation plays very greater role, and also soil structure interaction and considering the various stiffnesses. That means in the rainy season, in the dry season, we have to study, and differential settlements we have to account for in the soil structure interaction.
Yeah, now with this, we are almost coming to the close end of the session. So I think I would request sir to take one more question. Last question is that is from this question is saying, furthermore, adjusting for the stiffness in accordance with the mass distribution, a coupled mode behavior is observed, where approximately 10 to 20% torsional participation occurs within the translational mode. Since explicit codal provision for the design of such coupled mode dominates the building behavior and not clearly specified. Yeah, so what would be your suggestion, sir, on this thing?
No, unless I come across the real problem, I will not be able to give a solution to that. You know, it's so a very interesting question. Yeah. Not
general answers cannot be given. Yeah. I think there are so many comments coming up in the chat box, WhatsApp chat box. Excellent presentation, and I think the YouTube recording has been already done. So thank you, sir. Thank you very much on behalf of ISSE for excellent presentation, and thanks to all the participants for joining. So we announce a formal closure of the session. Thank you, sir.
Thank you. Thank you. And somebody is asking for the PPT, I can share it if they messages me in my WhatsApp. Yeah, no problem.
Great.
Thank you, Surya Prakash. Outstanding presentation. I think students must have enjoyed this, and a lot of information you have given to the students. Thank you very much, sir, for participating in the student event. Yeah.
Yeah, sure. Thank you very much.